Cisco Certified Network Associate. Hello everyone, this is your instructor Mr. Amir Hamza, and today we are going to discuss NAT with GLBP. NAT stands for Network Address Translation, whereas GLBP stands for Gateway Load Balancing Protocol. These are my personal as well as my company social media accounts, so you can follow me there, as well as my email address as well, so you can email me. I'll try to reply all of you, but if I don't, please do not be uh, please do not get naraz of me. Okay, so and before we go ahead, please click on that subscribe button and on that bell button to get notified about my every new video. And do not forget to click on the like button because that is your way of saying thank you. Okay, now this will be our topology today for our topic. Okay, now I have two PCs, virtual PCs. Okay, one switch. Okay, and one, two, three, four routers, four perimeter routers. Okay, for GLBP, GLBP is a redundancy protocol, so we'll use redundant redundant we are using redundant routers, so that if one gets down, the others are there to balance the effect. Okay, it is used in a big organization. Okay, now this is the internet router. We'll see that how is it configured. Okay, and now let's perimeter router 1 is not configured, we'll configure it. Okay, and perimeter router 2 and perimeter router 3 and perimeter router 4 have the same configurations as perimeter router 1, so we'll configure it by ourselves. Okay, ethernet 2, ethernet 20. Okay, and it is taking a bit time. Now I would like you to see this. Okay, configuring layer 3 redundancy with VRRP and GLBP. Okay, VRRP is also a redundancy protocol for that if one goes down, the other is there. Okay. Now GLBP is Gateway Load Balancing Protocol, single virtual IP address and multiple virtual MAC addresses. It says that if there will be a virtual IP assigned to the router. Okay, and and it will create a virtual MAC address to that IP address. Okay, you will see that. We'll see when you see the implementation, you will be cleared of the first point. Now, traffic to single gateway distributed across routers. Now, first of all, there was one gateway. Now there are multiple gateways. So, which because in this organization, internet is very necessary for them. Internet is like if internet goes down for them, their system will be collapsed. Okay, the system will just like Facebook, we are accessing their servers every time. For if their what if their server goes down, they can't let their server go down. If the server goes down, the end client just the end client is like, what, I'll not use Facebook again, what is this? Okay, do you understand? uh, Now let's attach one more cable. Oh, come on. Ethernet 2 1. Okay. Automatic rerouting in the event of any failure. If that is if any failure occurs, the, uh, the traffic will switch to another router. Okay, full use of resources on all routers without the administrative burden of creating multiple groups. We'll see that last point as well. Okay, okay, let's on the router. Have to come on. Okay. AVG, there is a active virtual gateway. It says that an active virtual gateway. Okay. Uh, GLBP group members select one AVG. Okay. Active virtual gateway. Active virtual gateway assigns the virtual MAC address to each member of the group. Active virtual gateway replies to ARP request and वगैरह वगैरह वगैरह. GLBP operation. GLBP1 IP this virtual MAC. Oh, interface tracking. Where is it going? It is very easy to configure it. I hope the slides are not um, doing you badly. Okay, let's finish it. Okay, let's console this router. This is perimeter router one. Okay, see, this is C7200 router, Cisco 7200 router, and it is opened with the port number. Just for the sake of knowledge, I'll tell you the port number as well. And see, it is port number 5006. Every router will have a different port number. Okay, every router 5012. See, every router will have a different port number in GNS. Why? We'll see that that is because of virtualization. Okay, okay, now come on, get on, man. Okay, this is our fresh router. See, it is we just it is not yet configured. Okay, I just want you to be sure. We will show the show running, and we'll get into the configuration of it. There's no problem in it. We'll do it like instantly. There's like no problem. 2 minutes, just 2 minutes. Okay, come on. Perimeter router 2. Okay, first we'll show you the, when we'll do the configurations, then I'll show you. Okay, configure terminal. Okay, you can also write configure terminal. Okay, configure terminal. Okay, we'll go to the interface Ethernet, the ingress interface, sorry, the ingress interface, that is Ethernet 20. Okay, we'll give it the IP 192.168.1.1. Interface Ethernet 2/0, IP address 192.168.1.1, 255.255.255.255.0. And just like this perimeter router 1, perimeter router 2 is configured with 192.168.1.2 and 3 with 3 and 4 with 4. Okay, exit this Ethernet 20 and we'll go to the interface Ethernet 2/1. Okay, interface Ethernet 2/1. We've configured with Ethernet 2/1. Okay, we can also write this Ethernet 2/ Ethernet. Come on. Okay. Ethernet 2/1. IP address. What is the IP address? 182.180.99.122. 255. You will be saying, yeah, how is this that why are we using these addresses? Because these are public addresses, from IPv4. Okay, We configured IP addresses on it. Now let's try to ping the other side. First we'll have to go to the internet router and give it interface ethernet 2/1. Okay, ethernet 2/1. IP address 182.180.99.121. Point to point IPs must be in the same network, okay? Then they'll only communicate. These are the okay. This is how we give IP. Okay, just like this, how we've given the IP on internet router. Okay, we can all of the other interfaces connected with Ethernet 2/2 is connected with perimeter router 2. It has this IP, just like we've given this IP. Okay, Ethernet 2/3 has this IP. Ethernet 2/4 has this IP, and there are loopback IPs configured. The virtual loopbacks. Okay, these are the these are the internet router IPs that are in Denmark, one in Sweden, and one in this router, one in that we are using this to connect. We are using this to check our connectivity. Okay, how to configure our interface loopback? 67, we can write IP address 67.67.67.255.255.255.0, and it is by default up. Okay, so when there's no need to. Okay, interface Ethernet 2/1. Now let's try to ping 182.180.99.121. Okay, it will ping. Okay, it is pinging, but let's try to ping what was the route, what was the interface loopback that we configured? 67.67.67.67.67. It will not ping this IP. Why? Because it does not know what to do with this IP. Our router does not know. So we'll have to give an IP route for that. IP route, a default route. We will 000 any IP. Take it to Ethernet 2/1, the egress interface. Okay, now let's try to ping that. It will ping now. See, it is pinging. Okay, now let's try to ping it with the source 192.168.1.1. It will not ping. Why? Because it does not know that how to do with itself. For that, for this source, we will have to we'll have to configure NAT. Okay, we'll have to configure NAT, because NAT will translate the private address to a public address. So that we will have to configure the interface from where the private address is configured, Ethernet 2/0 192.168.1.1. Okay, we will have to configure IP NAT inside, and when we'll configure this inside, a NAT virtual interface will be up. We'll see. Okay, it says NAT virtual interface. You see, NVI. Okay, very easy, right? And to the ingress interface, sorry, this was the ingress interface. We've given IP NAT inside over here, and to the egress interface, we'll say outside, IP NAT outside. Simple as that. Is it difficult? No, it is not. Yes, I'm listening. No. Yes, yes, it is very easy. So just like this, we've on perimeter router 2, on the ingress interface, we have from where the traffic will be coming 192.168.1.2. We have IP NAT inside, and IP NAT inside. Okay, and IP route is given, IP route 000 default route from Ethernet 2/1. 1, IP route to Ethernet 2/1, IP route Ethernet 2/1, IP route Ethernet 2/1. Okay. Okay. Hmm. Let's see how to give IP to a virtual PC. IP 192.168.1.40, for example. This is its IP, and then we'll give it subnet mask, and then the gateway's IP 192.168.1.1. No, 1.1. We will give it a virtual IP, a virtual IP that will be common in between all of these redundant routers. Okay, this is very important to understand. Very important.